people are coming in. That's why. Okay, well, good news is got some questions coming in. That's a good thing. And I will show that question that you had.
Does anybody think he sounds weird?
Not really.
Okay.
What's wrong? What do I sound like?
I don't know. It's like a weird echo. It could just be my internet connection.
For me, his mic is cutting out a little bit.
Well, my last class didn't have any problems, so I don't know if it's the traffic or if it's. Well, let me know if it gets worse, okay? Okay, the questions that I got, I need to get started because today I want to cover the questions that were sent and get into implicit differentiation because that's going to complete pretty much 80% of your testable material. And that's why I want to get implicit differentiation in. The questions that I received today, the first question, well, 3.3 and beyond. This first question is 3.3, 20 or 67/20. And of course, I usually tell you if it's a test question or not. This one I don't think is a test question because it's really, no, it is a test question. This is a test question. So go ahead and write it down.
The audio does sound a little garbled and grainy, but not excessively so.
Well, I don't know what it could be. How about now? Is it better now?
No.
It kind of sounds like the goldfish from Pinocchio talking underwater.
Thank you, Miss Sterling. Sounds like a goldfish. All right, well, let's do this. Let me cancel.
Do you happen to have like 2 microphones running?
No, I don't have 2 microphones.
Okay. I don't know if you have one on one computer by chance and one on
No,
another.
I don't have my other computer on.
Well, now you're fine. Now you sound fine.
Okay, well, let me know. It may be my internet. Okay, well, here's the question. Go ahead and write it down. Now, why is this a test question? Because the function is pretty simple. The reason it's a test question is because you have to use a little bit of critical thinking to understand what the question's asking. So f of x is equal to 40 square root of x minus 4x. Now, before we get started, hold on, let me pull up the handy dandy. Now, before we get started on the actual calculus, I'm going to take off from this, and I want y'all to tell me where is the tangent line horizontal on a function?
At the top of that one.
At the vertex where the tangent slope is equal to.
One message coming in on secured channel.
I'm supposed to have a meeting today. I told him I wasn't coming. Okay. So at the vertex on a parabola, where the slope is equal to 0, that's where your tangent is equal to 0. All right, so you might want to write that down because on some of these homework and test questions, it may ask you when the horizontal line or the tangent line is horizontal. And this is what they're asking for. So you have to set the derivative equal to what? 0. So you got to find the derivative, and then you have to set it equal to 0. So that's why this is a very good test question. So make sure you make a note that when they ask you where the tangent line is 0 or horizontal, that you have to set the derivative equal to 0. Capiche? Okay. So this is f of x is equal to 40 x to the 1/2 minus 4x. So that's going to be f prime of x is equal to 1/2 times 40 times x to the negative 1/2 minus 4. Now the calculus is done. We're done with the calculus. Now it ain't nothing but algebra. So I'm going to go ahead and write this as the calculus is done. But I'm going to clean it up. F prime of x is equal to 20x to the negative 1/2 minus 4. F prime of x is equal to 20 over square root of x minus 4. So if you want it in the simplified version, there it is. Now set that equal to 0. So 0 is equal to 20 over the square root of x minus 4. 4 is equal to 20 over square root of x. Multiply both sides by the square root of x. And you get 4 times square root of x is equal to 20. Divide by 4. Square root of x is equal to 5. X is equal to 25. Now you're not finished because it's asking for the coordinate. All right, so make sure when you start this problem, you got to find coordinate, which means an x and a what? Y. So you need to plug this back into the original. 40 times 5 is what, 200? Minus 100 is 100. So 25, comma, 100 is the answer to A. So I think Ms. Woodall sent this question. Ms. Woodall, if you're here, tell me if you sent it. I can't.
I'm here. I just sent it. That helped.
This is a very good test question. And the reason I keep repeating that is because I want y'all to know, and I've said this over and over and over, I am not going to test you on the people that attended Wimbledon and what was their addresses. I'm not going to ask you who invented derivatives and why. I'm going to ask you the mechanics. I'm going to test you on what you need to be a good Calculus 2 student. And a good Calculus 2 student has to know the basic derivative formula. And this is a good problem. And the reason it's a good problem is because it asks you to set the derivative equal to 0. And I'm going to highlight that right here. Because you're going to see a lot of times in your physics and your Calc 2 applications, you're going to set that derivative equal to 0. So that's A. B says, when is the slope equal to negative 2/3? Negative 3/2, sorry. So now instead of setting the derivative equal to 0, you're going to set it equal to what? 3/2. So I'm going to just half this. Now actually, I'm going to just do this. Instead of 3/2 and 1/0, we're going to say 3/2 is equal to 20 over the square root of x minus 4. Now again, we don't have to worry about any calculus because we already done the calculus. This is all algebra. Negative 3/8, sorry. So I'm going to add 8/2. Add 8/2. So that's 5/2 is equal to 20 over the square root of x. Multiply both sides by the square root of x. Divide by 5/2. Divide by 5/2, multiply by 2/5. Square root of 8x, is equal to 8. X is equal to 64. And you need to plug that in because they're wanting a coordinate. So that means an X and a Y. So plug that back in
320
to the original. What do you get?
320 minus 32, 298, right?
Hold on, I'll look at mine and see if I got that. I got 64. Check it. And that's B. Somebody check and put 64 into 40 times the square root of 64 minus 4 times 64, please.
It's 64.
Yeah, no,
So
sorry.
that's your answer for B.
Took the square root of the second x as well. That's what messed me up.
Yeah, it kind of helps do that. So far we've done, those are two good questions. And the reason I say two good questions is I don't try to give you questions on a test. I try to be fair and give you questions that are just single questions. I don't like to give 3- and 4-part questions. If I do, that's a mistake and I'm sorry. But I try to give you short and simple questions. So Miss Woodward, I got a Miss Woodward in my previous class. That's why I keep calling her Miss Woodward. Let me get out of that and let's check and see if we're right. I think we said parentheses 25, 100, close parentheses. And the next one is 64, 64, close parentheses. There you go. And that's a good example of a good test question and a good homework question and going over it like that. These are good. Like I said, there's 4 of them. We got about 4 of them to go over today. Here's one. This is 3.3 23/79/23. Well, my internet is certainly slow.
DOT cut
Okay.
a fiber line this morning.
Say it again.
DOT cut a fiber line this morning.
Oh, well, I'm on AT&T, so I hope maybe that's why. Okay, this is not a good test question, but I will go over it because it's real simple. But the way they've got it written, you have no earthly idea what they want. Now, I want to ask you, how many of you looked at this question and read the question and said, I have no idea what they want? Anybody?
Well, it doesn't look like they're even asking anything.
Exactly.
It just says G prime before.
This is exactly what I would not put on a test. Okay? What they're asking for, and I'm going to try to, I can't do it. I'm going to try to draw it. Let me blow this up because I can't draw on my screen because I don't have a whiteboard, which is coming. I ordered my portable whiteboard, so it should be here Friday.
Hina
So
Patel says they're here.
Say again.
Hina Patel says they are here.
Okay. Thank you. Okay. All right. Let me see if I can draw this. All right. 1, 2, 3, 4, 5, 6, 7, 8. And 8 on the other end. One, 2, 3, 4, 5, 6, 7, 8. And excuse me, 2. And this 3 and 5, 3, 1, 2, 3, 4, 5, and 8. All right, so the red is g of x. Okay, there's g of x. And f of x well, that looks like 3/4 and 8. 3/4 and 8. The things I do for y'all, 3/4 and 8, and then 3 and 1, or let's see, 3 and 1, and then I think that's going to be 8. 8 and 8, no, 8 and 6, 8 and 6. That's good enough for government work. Okay, here's what they're asking. They're wanting you to plug in the slope at F and G at 4 and put it in that equation. So this is what they're wanting you to do. Of course, the question does not say that. They're wanting you to get the slope, and I'm going to do that in another color. Let's go with green. At 4, 1, 2, 3, 4. Everybody with me? G of prime of 4 is -1. F of 4 is +1. So now you just plug it in. G is equal to 6 times 1 minus a -1. So your answer is what? 7. And I guarantee you there's some of y'all out there that goes, I had no idea that's what they were asking. On a scale of 1 to 10 of this being a dumbass question, it's about a 12. Okay? So this is not a question that I would put on a test. This is the type question that other teachers would put on a test just to confuse the hell out of you. And some of y'all know kind of.
I did this question and I did it completely differently, and it was a lot harder. I found the y equals mx plus b formula for each one, and then multiplied it out, and then did all of that.
Well, if they had not given you a graph, you would have had to do that. See, they gave you the graph, and the giveaway is that they gave you grids behind the graph. See, so you can actually see the 1 to 1, 1 to 1. See. So who was that said that?
That was Terrence.
Okay. Well, does that make better sense?
Yes.
Save you a little bit of trouble. Okay. So let me say again. That's a homework question, but it's not going to be on my test. If it is, I'll have to go in and take it out because I didn't put it on there. Okay. So I don't know who sent that one, Miss Woodall again. Hopefully that'll help you out. Okay, now these next 3 questions are questions that I would put on a test, along with the question we just did with the 40 times the square root. These questions were sent in today, I think, and they are very, very good test questions. Here's the first one. 3.1, number 12, or 2712. And my fever broke from my spider bite, so I don't have a fever. Yesterday I had a fever. This one looks, you remember, Mr. O'Quinn, you said that one was real rough, this one is even rougher. Why? You better make sure you write landscape on this one. And make sure you have a clean piece of paper. Now, if you want to cheat and use the chain rule, you can, but this is 3.1. You don't know the chain rule.
Is it still cheating though?
Yeah, it is. F of x is equal to x to the 5th power. And they want you to find, by the definition of a derivative, using the limit. And I'm just going to go through, I'm going to go through it, but I would not give you this on the test because it takes too much time. Okay? So here we go. I'm going to put big set of parentheses right here. Limit as h approaches 0 of x plus h to the 5th power minus xx to the 5th over h. Oops, I'm sorry. Now, what does that x plus h to the 5th, what does that do? Well, that's going to be x plus h to the 2nd times x plus h to the 2nd times x plus h minus x to the 5th over h. I've got two shortcuts there. X squared plus 2xh plus h squared times x squared plus 2xh plus h squared times x plus h minus 8x to the 5th over h. Everybody see where this is going? I'll take the silence as yes, we see it. So I'm going to distribute the x squared. So go ahead and be distributing that x squared. And that's going to give you x to the 3rd plus 2x to the 3rd h plus x squared h squared plus 2x to the 3rd h plus 4x squared h squared plus 2x h to the 3rd plus x squared h squared plus 2x h cubed plus h to the 4th, and please check me. We got to combine all those terms next. I'm not going to worry about the h right now. Okay, will y'all give me that? Will y'all give me that? Can I leave the h off right now?
No.
Okay, so this what?
Completeness.
Oh, I'm sorry. We still got to do x plus h times x plus h minus x to the 5th. So now I'm going to distribute the x, and that's going to give me x to the 4th plus 2x to the 4th h plus x to the third h squared plus 2x to the fourth h plus 4x to the third h squared plus 2x second h cubed plus x to the third h squared plus 2x squared h cubed plus 8x h to the fourth plus x to the third h plus 2x to the third h squared plus x squared h to the third plus 2x to the third h squared plus 4x squared h to the third plus 2x h to the fourth plus x squared h to the third plus 2x h to the fourth plus h to the fifth minus x to the fifth. Now, when you do all the simplification, you're going to get the following. I did this problem like 3 times just to make sure I had everything right. And that will give you x to the fifth plus 5x to the fourth h plus 10x to the third h squared plus 10x squared h to the third plus 5x h to the fourth plus h to the fifth h to the fifth minus x to the fifth over h. And that's going to take the x fifth is going to go out. The x to the fifth is going to go out. And that's going to leave you, and when you take the h out, that's going to leave you with 5x to the fourth plus 10x to the third h plus 10x squared h squared plus 5x h to the third plus h to the fourth. Limit as h approaches 0. And what happens to the h terms?
Bye-bye.
Bye-bye. So the derivative is 5x to the fourth, and they give you a point. X is equal to 1. So that's going to give you 5 times 1 to the fourth, which is 5. So m is equal to 1. I mean, m is equal to 5, and you've got a point 1 comma 1. So now you use the point slope equation. M is equal to 5 with a point of 1 comma y minus 1 is equal to 5 times x minus 1. Y minus 1 is equal to 5x minus 5. Y is equal to 5x minus 5 plus 1. Y is equal to 5x minus 4. Now again, that is not a question I would put on. I would put a x squared on the test, but that's it. I probably wouldn't put an x cubed, but I told you that way back when we were doing these. So let's check. Well, that's the answers. There's the answers right there. Capiche? So, look, I got a question, Miss Woodall. Did you even get that far on this one?
I did. I got the second part right, but I must have
Good.
had a math mistake in the first part.
Well, it took you a while, didn't it? I mean, it took about a half a page, didn't it? That's a good thing. That means you know your algebra. If you can do that problem, you know your algebra. All right, next question. This is 3.4, 20/9. And yes, it is a test question because a lot of 3.4 is going to be on the test because it's your basics. And I think this is, yeah, this is product rule. Again, it's meat and potatoes, just basic of the basic. F of x is equal to 7x minus 5x times e to the x. Now, the reason I put that dot there is to remind you that since this is multiplication, you're going to have to put this in brackets and do the what rule? The product rule, Hubert. That's right, class. So I want everybody to go ahead, if you haven't done a question like this one, I want you to go ahead and do that. And actually, this problem is not very long. First times the derivative of the second plus the second times the derivative of the first. So I'll drop it one more level and I'll take the derivative of everything. And I'm still going to put that in parentheses. And you can just write that as 5e to the x or 5x e to the x. And I'll do e to the x in blue, meaning that I took the derivative, plus 5. And I'll take the derivative of that 5x. That will be 5 e to the x. And that's pretty much your answer. The only thing is distribute the negative. F prime of that is equal to 7 minus 5x e to the x minus 5e to the x. And that is a good example of a test question. That not only has the power rule, it also has the product rule. So that's a good question. Next, 3.4, 24/12. Another good test question. Mr. O'Quinn, if you could, would you find the number for that question that you put up? Because that is a good test question. The ninth root of 3x over 9x minus 2. Could you find that? Because I'd like to make sure people notice that number. If you had it, if you don't worry about it. Okay, this is the question. Don't look at all this. Just write down the answer. I meant the question. G of x is equal to e to the x times 8x squared minus 16x squared, or 16x plus 16. Now, is this a time you would want to distribute? No. If you distribute it, it'd make the problem 10 times worse. Okay? So since you got a multiplication symbol right there, we're going to use the product rule. First times the derivative of the second plus the second times the derivative of the first. Well, I just overheard on the news that they're going to take off live PD. Well, that sucks. That's my show on Friday and Saturday night. I love watching that show. Anyway, guess we're going to take off everything. Elmer Fudd can't have a gun.
Hina Patel asked, when is our next test on these rules again?
Where did she ask that?
In the chat.
Oh, I've got the, hold on. I've got the attendance on. Hold on. I'm sorry. Okay. I don't have that. I have, oh, there it is. Okay, I'm gonna go off this right now, and I'm gonna go to the outline.
Just so you know, the outline you have posted, at least to my personal MyLabs Plus, has 0 dates put in it.
Yeah, it don't supposed to have dates in it.
Okay. It has a column of 4 dates. They're not there.
Fill in the dates. I mean, I'm not gonna say anything. I'm just gonna show y'all how to do it, and I'm gonna be quiet. I thought I had my last class already pulled up. Oh, well. Okay, the way that I usually do my classes, and anybody's had me before, it's the way I usually do it. As I go over a section, that's the section you should be working on. Now, I've covered several sections, and go to the outline. And I told y'all I was going to cover the main sections first. And those main sections are rules of differentiation, product rule, derivatives of trig, I went over those, and the chain rule. So that's 3.3, 3.4, 3.5, 3.7, and I also covered exponentials, that's 3.9. So that leaves implicit differentiation. Have I covered that yet?
No.
So you don't need to worry about it. Have I covered derivatives of inverse trigonometric functions? No. Have I covered related rates? No. I haven't covered 3 sections. Okay? And I haven't covered that 3.6 either. So right now, after today, or after whenever I cover implicit, there's one 2, 3, 4 sections I haven't covered. So that means you're responsible for all the other sections. So it means that we still got 4 sections left. And when I finish implicit differentiation, I'll go ahead. I usually don't put dates on homework, because when I put dates on homework, I'm always going to have half the class say, oh, I wasn't able to do it, and then I have to extend it. That's why I don't give dates on homework. But I'm having to do that in this class, okay? So I'm putting the date. So when I cover implicit differentiation, I'm going to put a date on it about 2 to 3 days after I covered it. And it's going to say, well, probably, I don't know if I put it not, but I'm going to put it on there. So when we get to the last 4 sections, which will be 3 to 11, when I get to related rates and derivatives of trigs, what should y'all be thinking about? Okay, I won't say it again. When I get to these 2, 310 and 311, what should y'all be thinking about?
310 and 311.
Meaning that's the end of the unit 1, or that's the end of this unit. So that means that what's coming up?
Test.
Test. So to answer your question, when I get to 3.10 and 3.11, when I cover derivatives of inverse trig functions and related rates, after I've covered implicit differentiation and derivatives of rate of change, that's when you should be waiting for a test. Okay, so here we go. We got g of x is equal to e to the x, and I'll take the derivative in blue. So that's going to be 16x minus 16 plus, and that's going to be 8x squared minus 16x plus 16. And the derivative of e to the x is e to the x. So now it's basically distributive law. And I like this problem because it'll whittle down to just about nothing. So distribute and that's going to give you g prime of x is equal to 16x e to the x minus 16 e to the x plus 8x squared e to the x minus 16x e to the x plus 16 e to the x. And what happens? 16x e to the x cancels, and the 16 cancels, and you're left with g prime of x is equal to 8x squared e to the x. That's the kind of problems I like. The ones that cancel out and get down to be just about nothing, that's the ones I like. Because you'll see a lot of those in your after Calc 1 classes. Mr. O'Quinn, did you ever find that number?
3.7.41.
It's posted in the chat.
Okay, thank you. That question right there, I'll go ahead and let you look at it. That's a good test question also. Now, the reason I would test you on this question would be the ability to rewrite the question and then use the chain rule inside of the rewrite. That's why. So just write this down right here, and I'll leave it up there for a few minutes in case you need it. Okay. And now I can get to implicit differentiation. Okay. So implicit differentiation. Well, I was going to show this. I had this already written down. Right now, there we go. Here's our priorities. Write that down. That's what our priorities is right now. Power rule, product rule, quotient rule, chain rule, trig, log, exponential, and implicit. This is 80% of your Unit 1 test. So I'm going to pull up that. It's a good thing that I did have that outline pulled up. I'm going to pull it up again if I can find it. There it is. So rules of differentiation, well, 3.4 is right here. I think these two, y'all check me. This is 3.4, and this is 3.3, and then the chain rule is 3.7, and then the trig, the basic trig is 3.5, and then the logarithms and functions is 3.9. And then today is 3.8. So by the outline, what 20% is 3.1, 3.2, and what 3.6, 3.10. And 3.11. And when I get to these two, that's when y'all need to start worrying. And y'all can, y'all know what I'm going to ask y'all out of 3.1 and 3.2. Definition of a derivative, x plus h. That's a guarantee. That's exactly what I'm going to ask you out of 3.1 and 3.2. Definition of a derivative. F of x plus h minus f of x over h. Well, we did one a while ago with the x to the fifth.
Just making sure we can't see what you're writing.
I'm sorry, say it again.
We can't see what you're writing.
Oh, I'm so sorry. There we go. So make sure you write that down, because right now we're going into 3.8. So that still leaves these three sections right here. Okay. So far, we've been doing derivatives based off of what? Off of a regular function. And the vertical line test tells us these are regular functions. If we did the logarithm, vertical line test, that's a function. So e to the x or 2 to the x, that is a function because it only crosses the vertical line test one time. So explicit differentiation is when you have a, quote, normal function. Everybody with me? Well, is everything in the real world normal?
No.
No, thank you. Appreciate the participation. So therefore, we have not normal. And we have what's called non-functions. So do we just throw away the calculus and say we can't do it, or do we find a way around it? We found a way around it. Now let me go ahead and tell you right now, implicit differentiation is very, very important in Calc 2, Calc 3, and DiffEq, especially DiffEq. So you might want to put a tab, a post-it note on this section of notes and these problems, and you keep your notebook, because in DiffEq, 3/4 of the class is implicit differentiation. Sound like somebody just gasped for air.
No, drinking coffee.
Oh, okay. So we're dealing with questions, we're dealing with problems instead of this. Where's my black pen? Okay, my black pen has disappeared. Instead of this, we're not doing those anymore. You're going to be looking something like, we'll start off with this one. Why? We're not doing these anymore. We're going to be doing something like this. Y, or x squared plus y squared is equal to 12. Now, when you're doing implicit differentiation, the only thing that you have to remember, and I want you to write this down, and I'm going to write in red, and I don't like to write in red. The only thing that you have to remember, take derivative of everything. Okay? You take the derivative of everything, but in respect to y, you put y prime beside it. Okay, write that down. Now that's a Hubertism. That's not going to be mathematical in any of your books. It's not going to be in your text. Okay? That's just plain words. When you take the derivative of this function, you take the derivative of every single term, but if there's a y, you have to put y prime beside it. Why? Because you have to solve for y prime at the end. Because the whole problem, in chapter 3, what is the whole goal? For you to find y prime. There's no y prime right here. You have to have a y prime. And the other thing, the chain rule basically tells us or gives us the y prime in the problem. Okay? The chain rule gives us this y prime right here and right here. And again, we could go through and do the variation, but it'd take about half a page and there's no sense in it. Whenever you see a y, you put y prime with its derivative. And we'll write that down. Whenever you see y, you put y prime with the derivative. That's the only thing you have to remember when doing implicit differentiation. So let's go through and do it. And I'll do the y prime in pink. So I'm going to go through and take the derivative. That'll be 2x plus 2y times y prime equals 0. Now you will see some books, they'll use dy dx here. I don't care. I think it's a whole lot simpler for you to use y prime because that's what you're solving for. As you grow in calculus, you'll use y prime less, and you'll be using more and more toward diffie q. You'll be using that. Okay? Now, if you want to impress your friends now, you can use that, but we're not using it. So here we go. Now, at this point, solve for y prime. So that's going to be 2y times y prime is equal to negative 2x. Divide by 2y, divide by 2y, and y prime is equal to, that goes out, negative x over y. Now I went through and I picked out problems that I would put on a test. And that's what we're going to be going over. All right, who's got a question on that? That's how you do implicit differentiation. Now I can tell you right now, there are some teachers that will lobotomize you over this. I hope I did not, but there will be some teachers that will make this difficult. Anybody got any comments, questions, concerns?
I mean, mechanically it looks simple, but what's the usefulness of it?
Well, when you get into second physics and second calculus, you need to find the acceleration and velocity of a point in time. You with me?
Gotcha.
Not only on a two-dimensional, but in a three-dimensional level. And when you get to the three-dimensional level, you're going to have to find the tangent so you can find the normal vector. And that's why you need it. Now, if you go into thermodynamics, you go into spatial fields, if you go into all that advanced math and advanced science, you're going to be using this a lot. If you go into, teaching math like me, you don't go into it a lot because you just teach the basics of it. But if you go into aeronautical engineering, you're going to be using it a lot. Does that answer your question?
Yeah, just trying to visualize.
Because I'll show you right quick. When you're using a three-dimensional graph, you with me? Oh, shoot, that sucks. And you've got an X and a Y and a Z plane. And you've got a point in space right here. That point in the space may be going in a trajectory like this. It may be going in a trajectory like this. Depending on where that trajectory is, it's going to have a function behind it. This is a function. This may not be a function. It may be a non-function like we're talking about. When you find this function or this non-function, then you got to find the normal vector. And to find the normal vector, you've got to have the tangent vector. And then you can find the normal vector based on the tangent vector. And when you get into air and speed, it's kind of, okay, the slingshot? that David supposedly used against Goliath, and he slung it around with centrifugal force, you know, a piece of leather about 3 foot long, and you put a stone in the bottom of it and you swing it. Well, when you come around, and I try to show it, when you come around with that slingshot, and here's your hand, and that slingshot has that stone right there, then you've got a force going this way, and then you've got a force going that way. Okay, and then you've got another force. This is the tangent force, and then you've got the normal vector, and then you've got the actual, I kind of drew it wrong, but you've got the actual acceleration, which is right there. So if you let go of that, whatever slingshot, that stone is going to go that way right there. So in order to find these details of that pink line, you've got to know these two vectors, which is the tangent vector and I drew it wrong. Technically, it should be like that. There you go. There's the tangent vector, and there's the normal vector. So, what were you saying? I'm sorry.
No, that works. I was just trying to link back to the real.
If you're going into Calc 2 and Calc 3, DIP-EQ, then that means that you're headed towards the sciences, the engineering. You're going to see it again. What were you saying, Miss Hart?
I didn't say anything.
I thought you said so. Sometimes y'all's circles light up, and I thought y'all said something. That's why. Maybe you hit something on your desk or something. Okay, let's do a nerd. I did some that I picked out. I'd like to try to find one. There's one. X cubed plus y cubed is equal to 8. Now, I'm a firm believer of crawling before you can walk. So naturally, are they going to get more difficult? Yes. We could start with the walking. All right, take the derivative of that function, or semi-function. Okay, so it shouldn't be that bad. I wish I would say something. All right, so 3x squared plus 3y squared times y prime is equal to 0. 3y squared times y prime is equal to negative 3x squared. Divide by 3y squared. And y prime is equal to negative x squared over y squared. Now, how many of you have had calculus before and got to this section and didn't know what to do? Just asking. Anybody want to volunteer?
Haven't done it yet, but it looks pretty easy.
It's not that difficult. Now, we're fixing to do one right now where you have to use the product rule. Okay, and it's going to add a little bit more to it, but it's not very difficult if you know how to use the product rule. So I'm going to let y'all work on this one. X squared plus 2xy plus y squared equals 5. And I'm going to put a dot right there so you'll know that I'm going to take 2x and make that the first and y the second, because you got to use the product rule right here. All right, get to work on it. I'm going to start you off by just setting it up. Well, that'll be 2x plus, I'm going to put my pink brackets, plus 2y times y prime equals 0. And I'm going to set up the middle. I'm going to use black for just writing the first and the second. First times the derivative of the second plus the second
Priority
times
one
the
message
derivative
coming in on
of
secure
the
channel.
first. And I'm going to take the derivative of those next. Okay, so I'll give you a second to. When I do the derivative of the green, I'll do it in pink so you'll see the y prime. So that's going to leave you with 2x plus parentheses 2x times 1 y prime, because the derivative of y is 1, but I got to put that y prime with it, plus y times 2 plus 2y y prime equals 0. Okay, y'all ready for this? Calculus is done.
Would there be a y prime with that second y?
No, because you didn't take the derivative of y, you took the derivative of x.
Gotcha.
So it's green. If I'm taking the derivative of a y term, I'm going to use a different color. I took the derivative of this, I got my y prime. This is 2x. There's no y there. This is first, it's black. I'm not taking the derivative of that. But who asked that? Mr. O'Quinn?
Yes.
That's why students mess this up. They think they have to do it with everything. You've got to write it out, and you've got to do it procedurally, and then grow into it. Okay, so here we go. I'm gonna simplify everything, and I'm just gonna write 2x plus 2x y prime plus 2y. Now, why did I change the pink 2 into, because it has nothing to do with y. So it can go back to black. Hang on, ACDC. Plus 2y y prime equals 0. Now, we all know what we're going to do next. We're going to take all the non-y primes, put them on the right, because this is just algebra. Let me, while I'm at it, let me go up here and go ahead and highlight this, because this is your calculus right here. There's your calculus. And I keep doing that all throughout the semester for a reason. Why do I keep doing that?
To show us mostly algebra.
Exactly, because a lot of people say they can't pass calculus because calculus is so hard. That's not it. So 2x times y prime plus 2y times y prime equals negative 2x minus 2y. Factor out y prime. And your final is y prime is equal to negative 2x minus 2y over 2x plus 2y. Now, I don't care about simplification. That's up to you. You want to factor out a 2 and cancel the 2's out. You can. It's going to carry. So y prime is equal to negative 1. Yeah, when y'all go by Martin Hall, y'all need to go down to the O level and visit Dr. Hardin's plaque. Those are 2 good test questions. Now, I do know that it's 4:25. I do want to show you something. We've got more to go over for the implicit differentiation. But I wanted to show you one thing. Here's one. And you can write it down and work on it if you want to, but it's not a... This is where we're heading. In fact, I got one more problem to show you, and then I'm going to throw a trig function in there. And there's the function. Tangent xy is equal to 7. Now, anytime you do you got to take the derivative of the tangent is the secant squared. And then that's xy. And then you got to take the derivative of what's inside. Product rule. So we're going to go into that tomorrow, or, when you come back. but I wanted you to see that's where we're heading. One more. Here's one right here. That looks complicated. I'll just write it because I got it written. 36 is equal to the square root of x squared plus y squared. Now that looks complicated, but it's actually very simple, 4 steps. Okay, so that's where we're heading with this. So my question, my suggestion to you right now, I have went over half of, what did I say, what section is 3.8? I've went over half of section 3.8. So you all as a class should be working on 3.8 tonight until you get to either some trig functions or some functions that we haven't done yet. You should at least be able to do 4 or 5 homework questions out of 3.8. Okay, I'm gonna shut the video off and call the roll. And y'all hang around if you got questions, and if not, you can